We'd planned the day that we would want this very special calf to be born. All our plans were aimed at getting the fetus mature enough to live when it came out into the air, and yet not so mature that it would come out by itself and we would miss it.
It's been a long 10 months. I lost a lot of sleep thinking, what happens if this animal doesn't make it? This could be a severe blow to the potential use of cloning technology in conservation, and felt like the whole world was kind of watching what we were doing. So I was pretty nervous.
I'm not getting it out this way.
Simply gets purified.
When I first heard about this plan to clone a gaur, I was very intrigued. A gaur is an ox-like animal that lives in Asia, and it's actually threatened in the world. There are very few individuals left. Somewhere between 13 and 30,000 are left in the wild. I think the fact that this species is a threatened species added a different element to the whole question of cloning. It's very different if you're using it for conservation than if you're using it for domestic species.
It's going to be a tough one to roll over, Jose.
She is. We got Noah's genetic material through a third party called Rescue. His cell line originated from the San Diego Zoo. The gaur died in captivity, I believe, in 1992. So the tissue sample was cryopreserved or frozen for about 8 years. What we wanted to do at the laboratory in Worcester was to apply a principle of somatic cell cloning, but to kind of put a slight twist on it by doing a procedure what we call cross-species nuclear transfer or cross-species cloning. And what that involves is taking genetic material from one species and fusing it to the egg of another species. We had a whole group of mature cow eggs that actually have cow DNA inside them. For us to be able to utilize those eggs, we have to remove the cow DNA. We then picked up an individual gaur cell that contained a nucleus that had gaur DNA present. Placed that cell into the egg. Applied an electrical pulse which allows the two components to fuse together. We then apply some chemicals that induce what we call fertilization events, and that embryo then starts to divide. We keep those embryos in culture for 7 days. We then ship the embryos back to Iowa at Transova Genetics, which they then transferred these gaur embryos into a domestic cow.
Got it.
So the whole project was done without ever having to come in contact with the living gaur. And actually that's important when you're looking at this in the field of conservation. There are so few of these animals left. Many zoos don't want us doing research on their gaur population. So we were able to actually produce a gaur without ever having to touch a living gaur.
That amnion's just a bit thick. You got the cord?
Come on here. I got the core. Core.
Yep.
Cool. It's coming. Cool. Come here.
The delivery itself is nerve-wracking for two reasons. Firstly, it's always a little bit tense because you don't know what is going to come out of the recipient animal, how healthy it will be and how much work you have to put into resuscitating it. So it's always a tense time when you get a neonate, a newborn animal, and you have to see whether it's going to breathe. But it was even more special in this case because it was such a unique animal, and it's the only one that we had to work with. If this one didn't live, there was no second chance. It would take another year or so to get more pregnancies on the way.
I think this type of procedure can be of some use in conservation biology. As a scientist, I'm aware that habitat preservation is extremely important and biodiversity is important for survival of a species. What we were trying to show with this technology was that potentially this could salvage genetics that would have been lost in a population. So in Noah's case, he was actually derived from a gaur that had not reproduced or allowed his genetics to go on to the next generation. We're now able to technically salvage that genetics that would have been lost from that male gaur.
Cloning has the possibility to bolster diminishing populations of animals. The question is, should it be used? My worry is that the public and politicians may think of this as an easy fix. Why conserve animals in the wild if we can go ahead and clone them in the future and replace them? The problem is that's absolutely not true. Biodiversity is so complex, and the interactions between species and their environment and within species are things that we can't replicate, as smart as we are and as much as we try. And I think the safest and best thing to do is to let biodiversity alone and continue as much as possible, rather than thinking that if we put our energy and effort into something like cloning, we can somehow replace what we've lost.
Bessie doesn't have a calf to look after, but she won't be missing that too much. She's not bellowing. She's recovered from the surgery, recovered from the C-section very well. And Noah is looking great because he can stand up. He's very alert and active. He's not as advanced as a normal calf would be at 12 hours, but we think he's doing just fine.
I'm kind of tired. It's been a long couple of days, every couple hours coming back, checking on the cow and then checking on the calf. And I think I'm still slightly in shock. Every time I go and check on Noah, I look at it and my first impressions are, oh, it's another cloned calf. And then I stop to think, I'm like, well, wait, no, this is actually a wild animal that's sitting out here. And then I think about it, I'm like, yeah, it's the first cloned endangered species. And it feels pretty good.